This is a water bailer, okay? If you notice, what will happen is that there's a ball bearing in the end, so it seals it at the bottom. And when we come to take, have you got the what's it, darling? When we come to take the sample out, we literally put a device on the bottom that pushes the ball bearing up and lets the water out. So what you do is we would quite literally push it in if it'll sink. Thank you, come on. There you go. You see that? Very nicely emptying. Now I've shook it up, and she's what you would do with the FID is the flame ionisation detector. You would quite literally then run the monitor, and because of Henry's law, anybody done A-level chemistry? No? Well, Henry's law actually, if you know what's in the headspace above, you can work out what's dissolved in the liquid, right? But you have to shake it up. Now, we're assuming that it's methane, right? Anything?
Nothing.
H2S?
4.
5.
Yeah,
So we're actually, look, we're picking, anybody want to come and look at the meter?
6.
Very quickly.
Yeah. The figures move.
But you
Yeah.
can see there's
Green,
hydrogen,
yeah.
there's
The
hydrogen
figures in green,
sulfide
yeah,
dissolved.
nice.
Yeah?
Yeah, there you go, your figures change. Yeah. H2S is the 6.
Dan
Watch,
just
the
pointed
pipe
out.
doesn't go in, Kez. There you go. Okay, it's dropped back down to 5.
Okay.
No methane in there.
By doing that, you can see we picked up the I shook the bottle, and the H2S has come out as solution, right? Now, if I know what the molecular weight is of the H2S, etc., I can actually work out theoretically what the concentration of dissolved hydrogen sulfide is, right? Because I've measured H2S. If I've got methane in there, I can work out what the dissolved methane is. And you say, well, why haven't you put the top back up? Well, you don't have to, because once you've shook it up, it's got sufficient kinetic energy. It keeps on coming out of solution, right? Because it's a headspace. So when it comes out of there, it knows by Henry's law, well, more's got to come out of solution, right? So it just keeps on coming out. Now, anybody that likes a pint of beer or a bottle of pop knows that the gas keeps on coming out, doesn't it? Right? Well, that's because it's been pumped full of gas, the beer, and it comes out and gives you a nice head, right? That's Henry's law, right? Dead simple. We'll take this sample, and we will analyse it for metals and non-metals, right? So we're sending it into the laboratory, and my lovely assistant. Oh, sorry, did I get you? What we'll also do is we look at a range of what they call TPHs, total petroleum hydrocarbons, right? And we'll do carbon ranges, okay? So we'll do a whole range of carbon, right? Now, normally it's like you can work out whether it's petrol, diesel, aviation fuel by carbon range, right? That gives you an idea, right? We'll also look at BTEX, which is benzene, toluene, ethyl benzene, and xylenes, right? They are normally associated with petroleum, right? We'll then look at, in the samples that we're analysing, or having analysed, we will look at VOCs. VOCs stand for volatile organic, carbons, organic carbon, right? So what we've got is we've got hydrocarbons there that might be halogenated. So you might have chlorinated solvents and things like that there. It gives you a baseline, all right? Then, because up to now we're actually targeting compounds, so we'll target things and we'll say we're going to have a look at benzene, and they'll analyse for benzene, right? But the chances are we won't find anything, right? Because we've targeted. Now, just because you don't find anything doesn't mean there's nothing there. It just means you've targeted things. So what we do is They are TICs, right? They're basically tentatively identified compounds. And what they do there is they look at the molecular mass and they do a guess, right, based on... So if there's anything there that's outside of the normal range, we pick it up, right? Anything significant that's measurable. It's a qualitative analysis, semi-quant, so you know it's 1, 10 or 100, yeah, you know the range. But if there's something there that isn't on the other list, we pick it up very quickly, because it's by gas chromatography, mass spectrometry, right? Okay, so you can then say, hey, we've got something there, we can target it. Now, going back to the simple analysis, you can actually go out and you can do pH strips, you can do your conductivity. What I'm advising you to do is to use CAD, so computer aided design, right? And to basically take as many samples as you can for as many analytes in your streams and your boreholes, right? It's not going to cost you very much. You can get the pH strips. One of the things that they use in the process is sulfite. Anybody make beer? Yeah? Sodium metabisulfite. Well, that comes out of solution, so you get a sulfur dioxide smell, but it dissolves. If it's not there now, and all of a sudden it starts to show up, there's a good chance it's coming from their process. So you want to target little things like that they might be introducing. All right. So it's spreading your net as far as you can, and bringing together as much information, and then plot it in CAD, and use what I refer to as Surfer, which does concentration profiling as well. Okay. Now you can get CAD. If you go onto line, you can get like a turbo CAD for 30-40 quid. You can also get some CAD programs free. Surfer, you just need somebody that's friendly, because it's a bit of a pain. But all you do with Surfer is you quite literally, you start off with your CAD drawing with your Ordnance Survey coordinates, right? And you literally put those coordinates into an Excel spreadsheet, and then basically you go plot, and it'll plot them for you. But you've got to be clever to do it. I get somebody that knows about it to do it for me. I know what I want it to tell me, but Velma's better at computers than I am. Most of the time, yeah.
It's too impatient, that's the problem.
It won't do what I want it to do. Anybody want to have a go at doing this? Anybody want to have a go? I didn't like that. And what you've got to do is bounce it up and down. Eventually it'll go underneath. Well, right the way down, right the way down. Bit more, bit more. Oh, there you go. A bit more, one again. There you go.
That's it.
All right.
Take it now.
And there you go. Now wash your hands.
That's it.
There you go.
Hold on, please.
I am holding on. It's you that's moving. What the people have said at Johnson Test Papers as well is that if we want to give them a list of analytes that we might want to look for, they'll devise some stuff for us as well. So again, if there's something that we're really concerned might be there, especially when we've got this data back, we might be able to get them to do something. All right, might. The analysis suite here as well, we're looking at polycyclics. So we're looking at polycyclic aromatics, so like things like benzoalpha pyrene, which you'll have heard about in terms of air pollution, naphthalene. The older people will know about naphthalene, it's mothballs. The kids won't have a clue what mothballs are. They never work, they just make your clothes stink. That water's cleared it up, isn't it?
Yes. Yeah, it does look clearer. Yeah,
Pardon?
You go.
Yeah,
Haven't you done any of the analysis? They have to take them apart.
Still
Yeah.
smells. Still smells.
Right.
Will you be picking up biostats, or is that an expensive process?
Well,
to detect those?
yeah,
Or
I
do
mean,
you just hope by detecting the other things it indicates
it
that
depends on,
the
you see,
biocides
are they going to be using biocides in the process?
Yeah.
Okay, so, and it just depends on, because if they have a mass spectrum, yes, we'll pick them up, right? Because they're organic molecules, the chances are that, you know, that's how they do the analysis anyhow. But not, I think a lot of the time with things like biocides, they might actually do it by liquid chromatography, so HPLC, high performance liquid chromatography. But
There's corrosion inhibitors and all sorts. Yeah.
we can have a look anyhow. We can have a look if it's
They
there.
Did, they did at Balcombe, didn't they?
The thing about mass spectrometry is that it picks up virtually everything. So you know, it's a good test in
Where
terms
is
of.
the mass spectrometer?
It's in Manchester.
Okay.
Yeah. We've got to take these samples home and they'll pick them up from us tomorrow morning. And then basically we'll keep them in a cool bag so that they're cold anyhow. But we do all this under chain of custody as well.
Yeah.
So what you have to remember is that any work that you do, right, my advice to everybody would be to have a notebook, right, like this lady, right, like Jill, write down what you've done, where you've done it, and the time, yeah, and then when you finish doing what you've done, you initial and draw a line underneath it, and that means nobody, it's like evidence then, that can be used, yeah, Police and Criminal Evidence Act, right, so by doing it that way, nobody can say you've added something, you've added, never use pencil, always use pen, write it in, yeah, okay,
On a day-by-day diary.
you do it as you, there's a word, contemporaneous, that means you do it as you're working at the same time, so you make contemporaneous notes. At least then you can say, well, it's professional, we've made contemporaneous notes, right, you're actually doing what a law enforcer would do, but you're actually doing it the other way. All right.